Boiling point of alcohols. In boiling point of alcohol, we look at the number of carbon first. As the number of carbon in the alcohol compound increases, the molecular weight increases. Same goes to the size of the molecule of alcohol increase. So the strength of van der Waals forces increase, thus the boiling point will increase. This is when we compare different compounds of alcohol. For example, we have 1 butanol, 2-methyl 1-propanol, 2-methyl 2-propanol. For this one, we have all alcohol compound, same number of carbon, but different branch. So 1 butanol has no branch. 2-methyl 1-propanol has only one branch or one substituent. 2-methyl 2-propanol has two branches. So 1 butanol has the highest boiling point due to its greater surface area because more branch reduce the surface area. The greater the number of branch, the lower the boiling point. This is only applicable for the same number of carbon and same functional group. Means if you have three alcohol compounds, but they have the same number of carbon, then you can use the reasoning for branch. If they are the alcohol compounds, different alcohol compounds, but they have different number of carbon, you have to use this reasoning. For compounds of comparable molecular size, the stronger the intermolecular forces, the higher the boiling point. For example, if you compare alcohol with the compounds that has functional group other than alcohol or no functional group at all, we compare them with alcohol. For example, this one we are comparing alkane, ether, and alcohol. First, you have to identify the intermolecular forces for that particular compound first. So for alkane, it consists of London forces only. For ether, it has London forces and dipole-dipole forces. And for alcohol, it has London forces, dipole-dipole forces, and hydrogen bond. So this order is the increasing boiling point order. So alkane has the lowest boiling point because it only has London forces. Ether has higher boiling point than alkane because ether has London forces and dipole-dipole forces, two types of forces, and dipole-dipole forces is stronger than London forces. That's why ether has higher boiling point. Now, alcohol has all London forces, dipole-dipole forces, and hydrogen bond. The hydrogen bond in alcohol is stronger than London forces and dipole-dipole forces. That's why alcohol has the highest boiling point. Now, we are comparing pentane and 1 butanol. First, identify the type of the molecule or the type of the compound first. Pentane is a non-polar compound, while 1 butanol is a polar compound. Pentane has London forces only between the molecules, while 1 butanol has hydrogen bond between the molecules. And you can also say it has hydrogen bond, dipole-dipole forces, and London forces. So the hydrogen bond is stronger than London forces, means the hydrogen bond in 1 butanol is stronger than London forces in pentane, so more energy required to break the hydrogen bond in 1 butanol. Thus, the boiling point of 1 butanol is higher than pentane.